I didn't even put this on. So we're gonna do that. And what is up, guys? Just gonna quickly share the stream link here and there, and then we can get started, right? Where's, oh, it's not open. Got it. Gonna pop the chat out, put it on my other screen, and there we go. Okay, 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 okay. Um, right. And I think we're ready to start. So what's up? Another day of lead coding. What, 10 subs? Let's go. Yes, that is a milestone that we did achieve, and I'm really happy with that. And for that exact reason, I'm gonna sponsor a bread pagoda for my dearest viewer. That's what you're gonna get for joining in all of these streams. It's my ninth stream today, and it's gonna be a 10th stream tomorrow. Like for the lead code sessions, I've had other streams too. That's crazy. And dude, you can't eat. Oh, you're right, 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 right. You're right. No oily food. Man, I've been living on scraps since this morning and I feel really shitty, really tired. And I picked up my guitar and played a few songs and now I feel alright. The meds work for you? I have no idea if they did. We'll find out tomorrow. We'll find out tomorrow. And I think it worked wonders for you. It's not. Well, whatever. I'm kind of jealous. I want something to work wonders for me. I want more energy, but I feel nothing as of now. Let's see tomorrow. So, share my screen. I finished the question that we started yesterday. It took a really long time. I'm not gonna lie, and honestly, it would have taken like another 30 minutes on the stream. But what's done? It's done finally. No, 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 no. Yeah, mute. Get muted. Why can I not find? Oh, I closed my chat. I'm trying. I should have gotten way better at this now. I do this every day. Close this, close this, close this, close this, close this, and close this, and open this. Switch to my screen. Right. Right, 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 right. So we're done with N Queen, and we've got these questions left. 5 more questions. These are all really interesting patterns. Let's do rat in a maze today. I'm gonna start with that because I'm already kind of warmed up because I finished the N Queens problem today. I did a few DSA questions. I joined a contest in the morning, but I think there was like 30 minutes left. Where's my bottle of water? Is it not here? It's not. I'm kind of thirsty. There were 30 minutes left in the contest, and I couldn't solve one question, a single question. So my ranking, like, I got a little demotion. You get 1500 as a beginner. 1500, I don't know what the rank is, whatever, ELO. You get 1500 ELO as a beginner, and I'm at 1470 something. So, alright, rat in a maze. Where can I practice this? I want to practice this. I don't want to consider a rat placed at position 0, 0 in an n by n square matrix. So all of these are n by n square matrices. That's what the question always is. The rat's goal is to reach the destination at position n minus 1, n minus 1. So I'm gonna open Excalibur. See all of these, just 2D matrices all the way. Anyways, you got this. I'll divide that in two parts. That's a 4 by 4 matrix. Right. So what we have is it's placed at 0 by 0 by default. I'm gonna draw a mouse. I don't like that. That's better. Elo just reminds me of something I used to play in my stat questions. Not sure how I should feel about it. It's been a while since we played. Right. The rat's supposed to reach this position. So I need to reach this position. I'm gonna create a flag right here. Oh no, no, not this color. This, and then it's a green flag because we finish. Right. And the rat's goal is to reach this. The rat can move in 4 possible directions. Up, down, left, and right. The matrix contains only two possible values: A, 0, a blocked cell through which the rat cannot travel; 1, a free cell that the rat can pass through. The task is to find all possible paths the rat can take to reach the destination, starting from 0, 0 and ending at n-1, n-1, under the condition that the rat cannot revisit any cell along the same path. Furthermore, the rat can only move to adjacent cells that are within bounds of the matrix and not blocked. If no path exists, return an empty list. Return the final result vector in a lexicographically smallest order. Barca won yesterday 3-2. Really? Aren't you happy? All possible paths it can take to reach the destination. Cannot revisit itself. Can only move to adjacent cells. Right, so if this is the input, 0 are blocked cells, so I'm gonna mark them with red. Let's just copy this over, because then we can add. But can I? Oh God. Right, get this, paste this in here. So it's 1. I'm just gonna mark the ones with blue. So it's 1 right here, and then 1 1 0 1 0 1, and then 1 1 0 0 and 0 1 1 1. Dude, you have no clue how happy I am. This is our second trophy this season. All of you football plebs are gonna move to fucking Europe. So I don't really care because you don't love our country. You see how that's a problem? Whoa, look at this. It gets filled in. That's so crazy. I love this. Anyways, what was I doing? Yes. So I got this matrix already. And I start here and then I look down. I need to return it in a lexicographically smallest order. Forgot to close my door again. Why does this keep happening to me? Wait, I'll go close the door. Have the keys next the wall to close on me. This is such a weird mic. I don't know how it's supposed to be placed. Okay, and I need it in lexicographically smallest order, so it's DUDLR. So to get it in a lexicographically smallest order, we need to arrange these from smallest to largest. So it's UDLR. So it's gonna be arranged as D R. No, L comes first. L R U. Right. A B C D A G H I J K L M N O P Q R S T U. Right. So that's how we're gonna move, and it cannot travel through the same one again. So basically what we do is we start here and then we mark this place as visited. So basically we erase the blue sign. No, no, why is it doing this to me? I'm gonna copy this and I'm gonna delete this. And then we can paste this right here. All right. So what happens is it checks if it can go down. It can. So it moves this mouse down and I group these together. I can. No. Yes. So it moves this mouse down and it erases these. And then it goes down again. Bro, God, GPT is saying we should eat boiled eggs because it might help with digestion and recovering gut health. That's all I want to mention. That's really nice. You know what I did today? Fucking I was making sandwiches and I didn't eat them because I thought that we cannot eat eggs today. Oh, well, it's Saturday. No, it's Sunday. Oh, I hate myself, and it was so good. I had like all these veggies and cheese and the right chutney, and it was awesome. It was fucking awesome. Right. So it's gonna create a recursive call for that, and then it's gonna check if it can move left, it cannot, right, it cannot, it up, it cannot. So this is the only recursive call it's gonna make, and then it makes another recursive call. All right, it goes down again. It goes down, and what is this emoji? It goes down, and then we take a string. Right, I think I got it. And then when we return, we got to mark it as no, it marks it whenever it reaches this place. And then it goes down, marks this, and then it checks. Stream is stuck. I need to check. I don't think stream should be stuck. Oh, it is stuck. That's weird. Chat GPT. I'm not even using Chat GPT. What happened, bro? Let me just go back. Is this another browser that it's sharing? It's not. Just a second. Switch here, switch back, and now it works. Okay, right. Thanks for telling me. Weird glitch. Anyways, I tried giving an interview to ChatGPT. Like I told it told ChatGPT that it was an interviewer, and then I solved a question. I couldn't get through the second round. I mean, I did get the intuition, but I had no idea how to use that data structure. Right, it moves this. Now I get it. I get what I need to do. So I'm just gonna start coding. So it starts here. Name it answer. Move this out of the way. Name it answer. Is it working now? It is. And then we're gonna call solve with the answer, the maze, current position 0 0, and this is the current position. I think that's it. Zero is a blocked cell. Well, we'll see what we need to pass, and then we return the answer. It's gonna be a private function. Private function called solve, and it returns nothing, so it's a void. Solve takes in vector string and ans and a vector int called maze and something else, and index a pair of integers called index. Right, we'll do the base case later on. Right now we're gonna, well, first you mark it as visited, so maze index dot first, index dot second equal to 0. You mark it as visited, right? And then you go down, left, down, left, right, right, up. So if to go down, you need to increase the column count. Column is less than it's gonna be image.size -1, because if it's at the last one, then we cannot go down. And right, maze we can just do the int call equal to index dot first int. It's actually the row index dot second. If column no, we need to go down. We need to increase the row. If the row less than maze dot size -1 and maze row +1 call is equal to, if it's 1, then it can pass through. Then it passes down, and then we can call the function again, ans maze pair no, index. I'm gonna do row plus 1 column, right? And to backtrack the solution, we're gonna do maze row column is equal to 1. Now we're gonna go left, and to go left, we need to decrease the column count. So if column is greater than 0, so it can be 0, right? And maze row for -1 is equal to 1. That means it can go left. Solve answer maze row for -1. Now to move right, we need to increase the column count. If column, oh no, wait, I also need to pass in a string that keeps track, right? Yeah, so it's a string called can you current, right? A string called current. I feel like it was, and that's better. I don't know. I don't know. Also need to pass that in cur plus d, and it's current plus L. And to move right, we need to increase the number of columns. So columns should be less than, it's in an n by n square matrix. So it's a square matrix, so we can just do maze dot size -1 again. Maze row col plus 1 is equal to 1. Then you do solve answer maze row comma column plus 1, and then current plus R. And to go up, if you need to decrease the number of rows, row is greater than 0, and maze row -1 same column is equal to 1. Then you do solve answer maze row -1 column comma current plus u, right? And then you make this again, check, and then make this one again, and then you go back. And the base case is if index dot first, I can just do this, right? If row equal to 4 equal to maze dot size and all maze dot size right, what's that supposed to mean? minus 1, minus 1. It means that we've reached this answer dot push back. Current is the thing we should do and return. I don't know if this is the most optimal solution. It's just, oh, I need to pass in more params. 0, 0 in a string, I guess. Right, it is the correct solution. I don't know if it's the most optimal one, but I think, I don't know if you can optimize it any further. Well, I didn't view the solution, but I don't give a fuck. Is there a way we can optimize this? Well, let me think. Right now we're just going, checking down, right, down, left, right, up, and then going there. Or you can start from this position, go here, and you won't exactly get dead ends. That's one way I can think of. Mm-hmm. Let's ask ChatGPT. That's the only way I can think of. Like, you reverse how the string is appended, and you start from here and go towards the starting. That's really nice of you. Make it so easy to test our solutions. Mm, As a quick breakdown, rad anyways, linear tree, points to consider. Is this the most optimal solution? It's not the most optimal. Current time complexity backtracking, large number of recursive calls. Worst case, yes. Because each 4 directions and then n worst complexity. Store intermediate results to avoid recomputation of same subproblems. For example, store the result of path from particular site to the destination. Mm. And if you reach that cell again, you can use a pre-computed result. A star algorithm, heuristic to prioritize paths that seem more promising, potentially reducing search space. A star would require calculating heuristic, choosing the cell based on the current state and heuristic, breadth first search. Right. A BFS visualizer. Got it. And what does the video say about this? Pretty sure you guys don't want to watch the video with me, so I'm gonna mute myself. I've got no idea if someone else is watching, bro. Yeah, I was thinking you guys don't want to hear this. Well, fuck you. You guys gotta hear this. You guys gotta hear this through my mic.
Oh yes, you can go right. So I can say this 3-1. It's a marker paper. And you decide to go rightwards, then it's 3, 2. So DD, RE, R. Since they want that rightwards, I'll click here. The yellow says I'll click here. Not possible. Okay. Already marked. You cannot come here. Okay. I go to 3, 3. And I will get a DD, RE, R, and R. This is my mark. This is my mark. I see that. I have moved to my destination. Yes, I have moved to my destination. Since I have moved to my destination, I can definitely print this as my answer. This is one. I'm marked right. So you take it right from here. Right? Can you go upwards? Not possible. That is an election. You went to right way. Can you so this is also wrong. So I again go back to 1. I make sure it is unmarked as well. I went down. I was just left. Can I go left? No. Not possible. Can I go upwards? Yes, you can go upwards. So I'm going 1. Now when you come back to 1, 0. I go down. Can I go down? Yes, I can. So I decide I go down. If I go down, this mark is visited. So I will go down with here now. That's F of 3, 1. And down directions. Down, left, right, up. Can you go down? D. And then the D was right. That was right. That is 1. See, I'm going to function. Right. Assume it's very first function. What am I doing? I'm going to produce the power. Okay. Function the auxiliary space, but that's nothing but this is how much n plus n plus n plus n. N1 is the auxiliary space. Yes, N1 is the auxiliary space in the worst case. We take this part. So all the movements and you declare input of vectors so that you can actually check for visit. And after that, you check if the source is 1 or not because the starting part of the source is actually unreal. Is it 0? It's very important that the 0, 0 is 1. And after that, you call the recursive function 0, 0. And initially, you have to take any step. So string will not be taking any. Right? So now let's look at the recursive function. So the recursive function has ij and it has the move string and all the other variables like array, all the data structure is going to show the whenever you reach there, that's your endpoint, right? So if you reach there, it'll be moved. That's already getting a index. So let's try it downward. So whenever I say downward, it means I plus 1 comma 2. Because downward means I plus 1 comma 2. So if it is I plus 1 comma 2, I need to check I plus 1. Is that it? If that cell has been visited previously or not, right? is a part. Yes, ij is definitely a part of your visit. And why they come back from this question? This ij, you write it if statements 8 10 that's a bit weird. So I'm going to teach you a technique where you can actually truncate this whole if statements into a single column. So let's check that out. Now, what are the possible directions? The possible directions that we are taking is down, right plus c. Okay, so that's the first addition that you're making, right? Now, the next one is the left. What is the left? I minus 1 comma j plus c. So when I say I is getting a minus 1 and j is getting a 0, why can't I have a di array and why can't I have a dj array, right? Because that is the deviation of I and j. Like it's simply to I plus di. And there's another term, right? It's down, left, directions. Just assume you cannot actually write it if statements 8 9 that's a bit weird. So I'm going to teach you a technique where you can actually truncate this whole if statements into a single column. So let's check it out. Now, what are the possible directions? The possible directions that we are taking is
Whoa, that
simply
sounds like something
n
really
plus 1,
nice.
j minus 1. Check for boundary, check for z, check for array, and then go as l. Similarly, you can for right, similarly, you can do for upward. But don't you think writing an individual code for every direction is a lot lengthy? And
Whoa,
if
almost
this
a day.
direction turns out to be the rat can move in 8 directions, then just assume you cannot actually write it if statements 8 9 that's a bit weird. So I'm going to teach you a technique where you can actually truncate this whole if statements into a single column. So let's check it out. Now, what are the possible directions? The possible directions that we are taking is down, left, right, up. So instead of writing 4 if statements, can I say that downward is nothing but I plus 1, comma j. These are the downward directions. So the I, the current index will get changed to I plus 1. And the term, the I stays to right. What is indeed increased by plus 1. Next is the upward term. When I say the upward term, why can't I have a di array and why can't I have a dj array? Right? Because that is the deviation of I and j. I can simply do I plus di of index and j plus j of index instead of writing, I was just writing 4f, first I by I plus 1j, then I comma j minus 1, and I comma j plus 1. Instead of this, I can simply iterate first time for this, then for this, then for this, and then for this. If I iterate, I will definitely get the movements first down, left, right, and then upward. You don't have to write 4 different if statements. Now I'm going to show you this in the code. So the function call, as you can see, I've been given the matrix and the etc. Again, these things stay pretty much similar. I just introduced a dr and a dj for the values that we have got. Okay, and we're calling the same solve function. And what we are doing is I is equal to 1 same. But instead of writing 4 different ifs, this time I've taken a direction dli, whatever you read with. And I'm doing the next jump that I'm going to make on x of I is I plus di of index and j plus G of index. That is what I have simply done. And I write next of I is greater than 0, next of j is greater than equal to 0. I just do all the boundary checks at once. And once I've done the boundary check, I check for visited and I check for a to be 1 upon. And if it is, I go and mark it as 1 and I come back and unmark it as 0. It still stays similar. Instead of 4 ifs, I just convert that into a for loop. So in this way, you can actually shorten your code. This is the way that you should do in your interviews, right? So guys, this will be it for the
Okay,
C++ code.
got
But
it,
I'll
got
give
it,
you the
got it.
link of the Java code in the description because it is exactly similar to this. Only instead of a vector, I'm using an array list, and everything remains exactly similar. So I hope you have understood the entire explanation, the entire code. And if you did, please make sure you like this video before you leave. And if you're new to our channel, please do not subscribe to us because that is
Whenever your heart gets broken, don't forget you're gone. I'll find a light out of the storm. Right. Close that, mark that as done. This is a really nice approach for condensing the different for loops. Word break. You want to do another hard recursive problem? And we can, right? Or we can also do this. Oh, easy. Look at these. Oh, shit. Why have I not done these before? Print prime factors of a number. Given a number n, your task is to find the largest prime factor of n. Prime factorization of 5 is just 5. How am I supposed to use bit manipulation in this? It's the largest prime factor of n. Well, let's see. You want all the prime factors, right? Um, okay. N can be to 10 to the power 9. That tells me for some reason this will take binary search. But I need to use bit manipulation for this. Well, there's an easy solution to this, which we all know about. Just start traversing deck from the end. Largest prime factors to 9. I am kind of tired. I feel so drowsy all of a sudden.
Need to run Windows on your Mac?
Oh,
Parallels Desktop. The channel. I hope you guys are doing extremely well. So what is the problem stating? You will be given a value n, and you have to bring down all the prime factors. Or what are prime factors? So if I write down all the divisors, basically all the numbers that divide 60, then that will be 1, 2, 3, yes, 4, 5, 6, yes, 7, 8, 9, 10, correct, 11, 12, 12, yes. After that, 15, after that, 20, after that, 30, and after that, the numbers that are prime and are dividing the number. Also one number. Do I see any other number? Probably no. These are the numbers, yeah, these are the numbers that are prime and are dividing this number n. These are the prime factors. You'll have to print 2, 3, 5. For 35, the prime factors will be 5, 7. For 780, the prime factors will be 2, 3. Well, you'll find it out when we divide. Or the easiest way to do it is 780 divided by 2, and then you get 390. You again divided by 2. What you get is 1, and keep is what you divided by. So the prime factors are 2, extreme naive approach. I think we can derive the naive approach from printing down all the devices. So if I ask you the extreme naive approach to this particular solution, you'll be like, maybe I can just find out all the devices and then check which are prime. So I already know how to check prime. I've already written this piece of code in the last lecture. How do you check prime in a time called basically of Vigo or square root of n? Maybe I can use it. So what I will do is, I take a list which will be storing all the prime factors. Let's start iterating basically of Vigo or square root of n. Maybe I can use it. So what I will do is, I take a list.
check prime in a root of 1. To check if I need to check if factors of the number exist. If factors of a number exist, we can go from 0 to root n. Root of the factor, right? From 0 to
You can just find out all the devices and then check which are prime. So I already know how to check prime. I've already written this piece of code in the last lecture. How do you check prime in a time called basically of Vigo or square root of n? Maybe I can use it. So what I will do is,
yeah, what's the code? And percent I equal to 0 count longer.
the naive approach from printing down all the devices. So if I ask you the extreme naive approach to this particular solution, you'll be like, maybe I can just find out all the devices and then check which are prime. So I already know how to check prime. I've already written this piece of code in the last lecture. How do you check prime in a time called basically of Vigo or square root of n? Maybe I can use it. So what I will do is, I take a list which will be storing all the prime factors. Let's start iterating from 2 because that is the first prime that I know of.
Checks if a number is prime. How does it check if a number is prime? Count equal 0 if n percent equal to 0. Count plus 1 if n per slash not equal to I. By I is not equal to I. Fuck.
The last lecture. How do you check prime in a time called basically of Vigo or square root of n? Maybe I can use it. So what I will do is, I take a list which will be storing all the prime factors. Let's start iterating from 2 because that is the first prime that I know of. I'll go till n itself because the number can be the prime factor itself, and then I'll go like I plus plus. But then, if the number n is dividing, if the number I is dividing n, and at the same time if that is prime, please check if that is prime. Again, prime check has been written.
I'm so fucking sleepy. Why am I so sleepy? Bro. 4 p.m. I am sleeping on the job and it's not. Okay, well, we can solve this. I know how to solve this. So, yeah, see, solved. So I can solve this. It's a really nice approach. Double my power, full extent, and x raised to the power n. Right, so basically what you do is, suppose it's 4 to the power 17. Well, you can say that it's someone sending me hearts. It's 4 raised to the power, well, if it's 17, it's basically equal to 4 into 416, right? And 416 is equal to 4 8 into 4 8, right? So you see what I'm trying to do. 17 is 4 417 into 416. 416 equal to 4 8 4 8, which is 4 4 4 4, is 4 2 4 2, which is 4 1 into 4 1, which is basically a base case. Either that was 0. So so if we reach the base case, we're gonna add a table that stores all of it. Let's just write a private function. Private double power. Yeah, I think I can just write it in here. If n is equal to 1, you return x. N is equal to 0. Can n be negative? It can be negative. Need to handle negative cases in a completely different way. X can be negative 2 and n can be negative 2. So well, let's just write it for positive cases right now. I think it's pretty easy to handle those. You return 1 if x is equal to 0, right? If n% 2, n is equal n and 1 is 1, that means it's an odd number, right? Yeah, that's the only way you can get an odd number in binary. So if it's odd, well, then you return x into my power comma n by 2 as you return n minus 1. 2, and then you return num into num. And you can create a table that stores all of this. Try and run the test case. A sec fault. No, okay, just remove these test cases for now. Wait, claim. So for 2.1, it's doing some weird shenanigan. Why would it do that? 2 returns 2.1 into I almost slept. I almost did sleep. So it returns 2.1 into my power 2.1 comma 2, and then this returns my power 2.1 comma 1, which is 2.1. So it returns 2.1 into 2.1, which is given to this function. And I can also create a private function called double pow x pow. So it takes in a double x and in n, and I want to create a map that has pair double and double called another. Yeah, so I'm gonna create this right here in this code too. And then we can get started here. And now we also need to handle negative cases. X can be negative and n can be negative. If n is negative, then if n is less than 0, it's -1, -2, whatever, then you return x power x minus n. So right, there's a case where both of them are negative. Wait a second. If x is less than 0 and n is less than 0. So I need to draw out the cases. So these are the cases, right? X is negative, x and n. So it can be negative, this can be negative, it can be positive, this can be negative, it can be negative, and this can be positive, and this can be positive, and this can be positive. In this case, right, if n is negative, then you return 1 upon answer in any case. I'm just gonna create a boolean that does that as my function. If bool neg power equal to false, if n is less than 0, neg power equal to true, and then n and to make n positive, n star equal to -1. N can be -2 raised to power 31, so I need to handle that case separately because I can't convert that into a positive number. Do it.